Here's a very quick demonstration of Kubernetes being deployed across two public clouds, Google and Azure. So here for our example, I've created a cluster in Google, and there are a couple of YAML files that I want to show. I want to start with pod.yaml file. And here, as you know, this is of type pod. All that is very standard. I'm pulling down an image from my Docker Hub repository. All that is pretty standard. And then this is the part that we want to focus on. On line number 23, we have volume mounts. And then on line number 26, we are defining the volume for this container. And instead of defining the details, whether it is an empty directory type of volume, we are saying that we are making a persistent volume claim with the name cloud storage name. Okay, and this is where things get interesting. So we are defining our requirements inside the persistent volume claim. Let's just take a look at the persistent volume claim code here. And once again, this is another type of Kubernetes object, persistent volume claim. And notice here that if I go further down, once again, there are no implementation details about how this claim is going to be realized. All we are saying is that we need 200 gigs of disk space here and of type access mode read write once, etc. So we are establishing a persistent volume claim which is being referenced inside the pod.xml right here. I showed you earlier, cloud storage claim is our name. It is defined in the persistent volume claim.yaml right here, cloud storage claim, and then we are defining a storage class here called the cloud storage, and we are defining essentially how much disk space we need. Now things become interesting. So how does the cloud storage come about? Well, the hint is in terms of which storage class are we going to use. So if we were on the Google Cloud, we would deploy a Google storage class, which means when the provisioning claim is being made, it will look for the provisioner that has been installed. In this case, the storage provisioner happens to be the Google GCE persistent disk claim. And here are the implementation details. We want them in a certain zone. We want a certain replication type. If the same storage class gets deployed in Azure, however, once again, I have the same storage class here. And remember, this is again the storage name, which we had mapped inside the persistent volume claim. And in this case, the provisioner happens to be Azure Disk. Okay. And then whichever cloud we are running in. So the beauty of this setup is that the pod.xml, which essentially defines my application, or in this case, just one pod, but it could be a collection of pod. Here I'm defining my application in terms of a container, which is the same across all the clouds, of course. And then we are not taking any hard dependence on any of the cloud providers. We are making a generic persistent volume claim, which will then get realized on Google using the GCE persistence disk, and on Azure, it is going to get realized using Azure Disk. Okay, so let's see this in action. So right now I'm in the Google shell. Let me go ahead and see if I have any pods. I don't. So let me just go run the pod.xml file that we just looked at. So pod.yaml. And looks like our pod did indeed get created. So right now it is getting created. We'll come back to this in a moment. And I'm going to switch tabs here. And I've created an AKS cluster, exactly the same pod.yaml file. Here, however, the provisioner is the Azure Disk. So let's just go ahead and run this and see if there are any pods. There are no pods here. Okay, so let me just run that command that we ran on the Google Cloud here, and pod.yaml right here. And if you run this, the pod got created. Let's just see if it is also being created right now. And the extra few seconds that you're seeing is because it is dynamically going in using the storage class on the respective cloud and provisioning the appropriate, in case of Azure, and Azure Disk for us. So let's just see if the Google Cloud was able to go ahead and create it. Looks like our pod is running. And let me just go to the Azure portal or Azure console and see if our pod is running. So it looks like our pod is running in both instances. Okay, so I'm just going to make sure we have everything set up correctly. I'm going to describe this pod, my pod, so we can see if our disk got mounted correctly. So if you look at the events, it pulled down the container image from my Docker hub, and it got mounted correctly. And if I go up here, it is going to show me all the information about the persistent volume claim. This is the cloud storage claim, and so on and so forth. Okay, just to verify that our volume indeed get mounted, in other words, our persistent volume claim was realized, let's just do this. And I'm just going to run this command. And it comes back and shows us that all I'm doing is I'm directory listing this drive. Why am I looking at this file? Let's just go back to pod.yaml. And here inside the volume, I'm defining a persistent volume claim. And notice here the name volume. And if I go inside the container specifications inside the volume mount, here is the matchup of volume. And it is telling us that the mount path is /mount cloud storage. So I was able to exec into that pod and do a directory listing of this directory right here. Let's just try to do that on the Azure side here as well, since our pod is running. So we can do k exec -it -pod, do the same thing here, and we should see cloud storage here as well. And what is interesting is one of them is being fulfilled using an Azure disk. The other one is being fulfilled using Google Persistence Disk. So that concludes this demo. Let me bring up the files that we had originally. And this is why these collection of files, the pod.yaml, which defines our pod, and then the collection of storage classes here, which are cloud specific, make our code base essentially portable across these clouds. So hope you found this useful. Send us any questions if you have any. Thank you.